Good morning, everyone.
Morning.
Really? Oh, come on. Come on. You have to do a little better. Good morning, everyone. Okay. So I am super excited to be up here. Number one reason why I'm super excited to be up here, I do not have to present up here. And that's actually the real reason I'm super excited to be up here is because I'm really excited to introduce your next speaker, Titus Winters. And I have a small story to tell to give you an idea of how I got to know Titus professionally. You see, my team and I, we built a bunch of C++ tools, amazing C++ tools, miraculous. We were sure they were going to change the landscape of C++. They couldn't be beat. It was wonderful. But we made this critical mistake. We forgot something. Tools do not have impact. I know everyone's like, wait, what? Tools don't have impact. They don't. They really don't. Tools can't change the world. People use tools to have impact and to change the world. And Titus and his team used our tools to change the world of C++ at Google. And he turned our C++ code base from something that was falling down around us and that we didn't know what to do with into something sustainable and maintainable for years and years to come, for decades to come. He turned our developer ecosystem and our developers from some kind of den of confusion and frustration and angst into actually a productive and happy and empowered and informed community, right? And that's why I'm really excited to be up here and introducing him. However, I'm supposed to be up here telling you why you should be excited to listen to Titus, and I can't do that. So instead, I'm going to ask you all a question. Why are you here? No, I'm dead serious. Why are you here? And you should be asking yourself every day, everything you do, why am I here and why am I doing this? And I suspect a bunch of people here, how many folks here are here to learn something in some way or another, right? Right? To grow, to improve, right? Incrementally, year over year, I hope, right? In conversations in the hallways with new ideas and revisiting old ideas, listening to great talks. But to learn, we need a teacher. And Bjarne reminded us yesterday of the importance of teachers. And so it's my pleasure to introduce the person who taught Google to write better C++ and to write C++ better. The finest teacher that I've had the pleasure of working with at Google, Dr. Titus Winters, to teach us about living ahead.
Thank you, my friend. All right, so C++ as a live-ahead language. We certainly know some of those words. This is a deep and esoteric, in some moments, sort of topic. But in order to get into that, we need to sort of set the stage. We need to motivate it. We need to start with a story. And getting here required moving through Google and working with the Google code base. And much of this story is sort of a history of Google's C++ code and portability. Historically, Google has had pretty limited portability requirements. For many years, we controlled our tool chain and production environment. Chandler controlled it very well. There were some projects that had unusual portability requirements, things like building Google Earth for Windows, but it was an extreme minority, and our focus on it was sort of largely an afterthought. Such an overwhelming majority of our code had completely controlled constraints that it just wasn't worth focusing on other things. And you can sort of see this in our interactions with some of our open source projects. Early on, we built cool things and we wanted to share them. We just put out things like G-flags and logging and Google Test and all of these things. But then, as our control over our build and production environment got better and better, it sort of stopped making organizational sense for us to spend a ton of effort providing those libraries for platforms that we never touched. It was very outside of our needs. And so our interactions over time, over a decade, sort of dwindled. And that started changing on the upswing a little while back. Mobile, shockingly, has different needs than production. Our open source projects that support cloud have different needs still. And we sort of managed to put blinders on and muddle through regardless for a while. But eventually it did become clear throughout the organization that we needed a different approach. The era of Google's code base doesn't need to be like everyone else had come to a close, and it took us a while, but we did realize that. On the other hand, that era gave us amazing experiences and powers, things that we've spoken about previously, talks that I've given colleagues from former teams, Hiram Wright. While we only had a single platform that we cared about, it was easier to do things like write tests and impose rules like our Beyoncé rule. If you liked it, you should have put a test on it. This is the type of rule that allows janitors and tool makers and compiler team to make changes to the infrastructure that literally everything in our code base uses with confidence, right? If your team actually wanted your code to not break, you needed a test for us to validate against. This monoculture made things possible. Now we make changes at scale. Millions of edits are not just possible, but actually pretty straightforward. My team next quarter will almost certainly make 1 million edits to our code base. I would be surprised if we didn't get to that number. We've evolved to the place where anything that needs to be changed can be changed. We are sustainable. That is very powerful. So a couple years back, when our leaders started taking other platforms and code portability seriously, I really wanted to ensure that we didn't lose that property, that sustainability. When they started talking about funding efforts to improve code sharing, I made sure to get involved in those directions early. I shared what I knew and what I wanted to ensure, and as a result, I got tapped sort of broadly to make code sharing between our code base and the rest of the world more feasible. This talk is really about two things. One, Google is open sourcing a bunch of C++ common libraries. These are the bits and pieces that underpin literally everything we do. And I want to do this in a way that doesn't impact our ability to make changes, but that is also good for users. And that is a difficult balance. There's not a lot of great examples for how to pull that off yet. So this is what I'm going to try to motivate. The discussions that have happened comparing our internal development strategy and how the rest of the world works have been illuminating. To really explain things and to make this worthy of a plenary talk, this is a big stage and a big audience, I want to step way back and look at some sort of core software engineering practices. And first, software engineering. These are the things that we do when we work on a project, why we do it. I want to be a little bit like the kid that asks why over and over to get to some more abstract stuff. Get us to take a look for a while at sort of basic software engineering practices, or when I'm being snarky, software engineering orthodoxy, and get you to evaluate why you do the things that you are doing. But first, we can't really look at those practices of software engineering without some working definition of what is software engineering. We all know what programming is. But what is the difference between these two things? Why do we have two words for these concepts? Software engineering, to me, is programming integrated over time. I'll put this another way. A programming task is, oh, hey, I got my thing to work. And congratulations. Programming is hard. And a lot of the time, the right answer to a problem is, I'm going to go write a program, solve that problem, and be done. Right? That's great. No judgment, right? Totally fine. Engineering, on the other hand, is what happens when things need to live for longer and the influence of time starts creeping in. The library that you used has a new version. The operating system you developed for has been deprecated. The language you wrote in has been revised and you need to update. The requirements have changed and you need to add new features. Other developers are working on it. You're moving to a new team. You're moving to a new computer. Your hard drive died. Time happens. Things change. How you handle that and how you keep your programming working is engineering. It may bleed into the programming itself as you plan for change within the structure of the code, or it may be entirely layered on top when your quick one-off hack becomes enshrined as a critical feature of your team's tool set. build tools, Dan. The first time I can remember having this thought, engineering as programming integrated over time, is still relevant. This is optional versus required in protobufs. People at the company for longer than I and smarter than I started saying, required fields are harmful. Let's ask why. Protobuf, if you remember, is the message format, sort of like JSON, that we at Google build all of our RPC services out of. In the early days, you'd define a message maybe like this. The name of this type is request. It has a single field, query ID. That field is required. It's a 64-bit integer. The name of the field isn't present in its wire encoding, just the ID number of the field, 17. If a process is sent a request that doesn't have a 64-bit integer in ID 17, it will fail to parse. The request just dies before it's even made it up the stack to the RPC level. And logically, that makes sense. You can't process without the request. Or you can't process the request without this ID. Why would you think you could? It seems perfectly reasonable to make this required. But what happens when time creeps in? We change the service to have a different option. What if you provide the raw string instead of a pre-computed query ID? In that case, we aren't sure which one of these will be present, and so maybe we make both the ID and the string optional, and we do the validation at a higher level. What's that look like when we deploy? We have some front end that is sending requests to the back-end server. Unshockingly, if we deploy the front end first, we'll start sending maybe request ID or maybe sending request string. And the server, remember, is somewhere back in time. It is still running with the old definition. Right? In the server's view of things, the ID is still required. And so if the server is configured so that that garbage request is an assertion failure or just silently ignored, things go sideways. None of this is surprising. Right? We update the server first. This is very in line with everything that everyone knows about writing protocols. You need to be strict in what you omit and liberal in what you accept, so clearly we have to update the backend first. No shock. Make sure we're capable of accepting any definition. But what about rollouts? What if there are multiple servers? What if we don't upgrade all the servers at once? That does seem safest after all. We know the previous version was working. Updating all the servers to the new version at once might be catastrophic. So we do some of them and then the front end, and if the front end doesn't know the difference between which ones support the new thing and which ones don't, then we're back to the same problem. Right? This only gets worse when you start having complex networks of servers. I could not possibly draw the graph of server interconnects in Google production. Right? You do not want to get into a situation where every service in the fleet has to be restarted all at once in order to handle a protocol update. And so we could, of course, fix this by adding version fields to every message definition, but that in and of itself is still adding time to the protocol. All of this complexity is fundamentally a different flavor than I got it working. It is fundamentally a different flavor than programming. And it is completely unnecessary in some contexts. If you know that your program or service only needs to work for a limited time, right? I need to get it today. I need it to last through the demo. I need the next round of funding. We don't need to plan for the future. Then you don't plan for the future. That's fine, right? Context matters. But when you aren't certain, when you have to be prepared, and that preparedness is what I look at as software engineering. It is the impact of time on a programming system. And the point of this whole anecdote is that something that makes sense on the face of it, required fields, turns out to be a horrible idea when you start thinking about change over time. And I would argue that there are many things that we do that make perfect sense in a limited domain, in a programming domain, but do not necessarily make sense when we are thinking about it as engineering and change over time. At the core, I think everything that we think of when we talk about software engineering tools and technology is about resilience to time. Version control is about being able to go back in time, coordinate with your colleagues over time. CI, continuous integration, is about making sure that recent changes haven't broken the system. Unit tests are very similar. This is make sure the feature that you wrote hasn't been broken by the idiot down the hall or you in the future. Refactoring tools are how you update from an old way to a new way. Design patterns give you some ability to plan for future changes without knowing exactly what those changes will be. Dependency management is how we deal with the fact that the libraries we depend upon may change. And that last is really crucial in what I'm going to talk about for a while here. Let's talk about dependency management and the fundamental problem in dependency management, diamond dependencies. Diamond dependencies are the bane of package management, content management, dependency management, any sort of management. And they arise commonly in cases where multiple libraries depend on a lower level library. Here we have lib.a and lib.b. They both depend on libutil. As soon as versions change, there's now 2 green boxes for libutil. If everyone in your infrastructure doesn't upgrade at the same time, then we have version skew. Lib.b depends on v2, lib.a depends on v1. This is even now still fine in theory until some additional package, maybe yours, chooses to depend on both of the mid-level libraries. Now we have a problem. You are the pink box. In some situations, for some languages, we can make this work by compiling in both versions of libutil, so long as there are not types from libutil that pass through both of them into user code, and so long as there's not global initialization in libutil and a long host of other things. But in general, for many languages and for many situations, this just results in failed builds, or maybe in some cases worse, failed runtime problems. There is a standard mechanism that we use for identifying this problem, and it is so ubiquitous, it's even worked its way into this diagram. When discussing 2 incompatible versions of libutil, my instinct is to describe these as versions 1 and version 2, not 1 and 1.01, not apple and orange, not A and B. Clearly, I describe these as 1 and 2. This is what was intuitive to you as well, I'll guess. We've come to take it for granted that version numbers are what identifies a release, and changes in major version indicate some level of incompatibility. You changed a thing. This is what we call semantic versioning, and it is the standard answer for versioning and dependency management. Semantic versioning, just so that we're all on the same page, generally gives us version numbers of the form x.y.z, 1.3.17, for instance. The rightmost number is the patch number. These are things that shouldn't affect anything, just a bug fix. The minor number, the 3, is a minor additional release. We've added some new APIs, things that weren't present in the old thing, but nothing has changed, no one will be broken. And the major number bump is reserved for, I made a change to an existing API, your code won't build. So when you express dependence on a particular version of one of your underlying libraries, libutil, you say, I depend on 1.3 or better. And 1.3 or better means could be 1.4, could be 1.5, can't be 2.0 because in that 1 to 2 switch, you made a breaking change. Scare quotes. Implicit in the system is that you can tell the difference ahead of time between a change that breaks someone and a change that doesn't. And it's actually sort of worse than this. Using an incompatible major version doesn't mean that things won't work. It just means things might not work. It is entirely possible that the major version got bumped because of API changes that you don't actually care about. That is, imagine that lib.a doesn't depend on everything in libutil, only one part of it. Changes unrelated to APIs in libutil may not affect lib.a in any meaningful way. And yet, in a semver sense, we've revved libutil to v2 and a new major version because there was an incompatible API change. So in some instances, semver is over-constraining, which if you've ever had trouble installing something because of version incompatibilities, is not a pleasant thought. I think it has been a week since I had that annoyance, and I would give you better than even odds that if we just made it shut up and turned off all of the version checking, it would probably work. Very annoying. But assuming that you can identify what breaks your users and assuming that you're okay with that slight over-conservatism, this does give us a standard way of identifying things that will work together. Note what semver doesn't say. This is not providing any form of proof that your dependencies can work out. It is just saying that if there is a set of versions for your dependencies that satisfies all stated constraints, you can, in theory, find it. And of course, each version of all of your dependencies comes with its own requirements. And it is especially important to note that any dependency tree you see that fits on a slide is wildly simplified. and that popular dependencies are very popular, and that diamonds form at many levels and scales. And as your dependency graph grows, it grows quadratically. That is how graphs grow. Only a linear fraction of your dependency graph is under your control. You are the pink box. You get to pick the things that are directly depended upon by you. You do not necessarily have control over the dependencies of everything else in your graph. Do the math. The chances that semver and its potential slight over-constraining leaves you with an unsatisfiable dependency tree grows quadratically. We are doing better and better in the open source world of making things shareable, and we are heading to disaster. Why do we use semver? It is a compromise position between nothing ever changes and there is no stability promise. There is nothing about this that is necessary, nor is it in any way sufficient. As your dependency graph expands, dependence on semver is equivalent to, I sure hope that major version bumps in my graph happen sufficiently infrequently that this all works out. It's a hope and a prayer. What's the difference between a patch release and a major version? It gets worse. That is, what guarantee are you giving when you bump from 1.3.17 to 1.3.18 that you aren't giving when you go to 2.0.0? That is, put it another way, what constitutes a breaking change? And because I've done quite a bit to change and update Google's codebase over the years, I can answer this quite confidently: almost everything. Breaking changeness is not binary. It is shades of gray. Almost certainly fine, or boy, we sure hope so, adding white space or changing line numbers. Clearly this should be fine, right? In any language that has even the most primitive reflection properties, C++, say extract, get me the current file name and line number in this file, it is theoretically possible for production code to depend on those properties. This is the stupidest factorial implementation of all time. Slide code is by its nature ridiculous. But you can certainly imagine that spread over 10,000 lines of actual production code, something that reduces to this could, in theory, exist. And practically speaking, if you saw my talk on tests a couple years ago, because log statements tend to include file name and line number, brittle and poorly designed tests regularly do depend on file name and line number. We shouldn't care, but we also should not pretend that this does not have the potential to break something. On the more extreme end, removing a public API. This is clearly a breaking change. Everyone would agree with this. This is the type of thing that everyone knows, recognizes a break. This is not contentious. But at the same time, if you've had an API that's better in every way for 5 years, for 10 years, for 20 years, do we really have to continue supporting the old thing? What if you go talk to Chandler and you're like, hey, Chandler, can we just have a tool that updates everyone from the old thing to the new thing, just provably? Can we delete the old busted API then? Even the delete a thing that is clearly a breaking change isn't entirely impossible. What about things in the middle? How about adding an overload? Is this a breaking change? Oh, in C++, this is a breaking change. If someone is taking the address of your function, any function pointers, this is almost certainly going to be a break, right? You have changed the functions, or you've made it ambiguous which function you wanted out of that overload set. Build break, right? We'll hit more on this later. So is that a breaking change, adding an overload? What about changing the number or alignment of members in an object? Someone could be depending on that, obviously. Or runtime efficiency. What about cases where runtime efficiency gets better for almost all callers, but some of them regress? Coming up with a definition for breaking change is hard. No matter what we do in a Hiram's law sense, someone could be relying on every observable. And as the number of users of your API goes up, the odds of someone relying on every observable behavior of your API goes to certainty. I'm going to include a slide on this whenever possible until everyone else is quoting it. As far as I'm concerned, this is one of the great practical constraints in software engineering. HiramsLaw.com basically is just that quote, but we miss you, Hiram. And there is, of course, an XKCD for this. Here, a clever user is relying on a bug in their keyboard drivers to configure their Emacs workflow and then complaining about the bug fix. So, semantic versioning. This is the thing that we all use to avoid having dependency problems. This is based on the idea that we can tell the difference between a change that breaks our users and one that doesn't, even though Hiram's Law tells us better. Or if we're being charitable, it tells us about changes in API and assumes that non-API changes don't matter. Semver identifies correctly when the versions that we have installed theoretically don't work together. It is possible that in practice that they do, if the API that caused the major version bump is unused, or any host of other scenarios. I could draw a comparison here to supporting C++ language versions. As it turns out, C++ 11 support was not a binary thing. We might still disagree a little bit on whether any given compiler really implements it. Expressing your requirement as requires C++ 11 turns out to not be entirely useful. Collapsing things that are complicated down into a single dimension for support is theoretically satisfying, makes great graphs on whiteboards, but it is not very useful practically. The Semver constraints do not promise solutions. They merely promise if you are able to obey these constraints, things will work. The likelihood of over-constraint leads to unsolvable constraint problems, and this grows quadratically. As the frequency of major number bumps goes up in your dependency graph, you are increasingly likely to be stuck. But when it works, we don't have to worry about diamond dependencies, so that's great. Those are important because those are hard. And let's look at really why these are hard, not what we currently do to work around it. Diamond dependency. Think about you as the pink graph here. You are not an expert in the code that has to change, lib_a, the code that did change, libutil, like why did they change this thing? I don't know. And whether or not any change that you happened to make to lib_a to fix this works. It's a whole lot of no idea, dog. There are three things I've seen that make this work in theory, that avoid the diamond dependency issue. Nothing ever changes over time. Good luck with that. Add a level of abstraction. We're just going to draw a bigger box. That doesn't really scale. Or the group making the change needs to update everyone, the mono-repo approach, or make it trivially easy to do the update, even by a novice. When you phrase it this way, we have so completely solved this problem in the last 5 or 10 years. We just haven't stepped back, asked why, look at why we do the things we do, and considered the full impact. Let's look at some of the technical and conceptual changes in the last few years and come back to the idea of what would it take to make upgrades easy for a non-expert. What happened recently? Unit tests are on the rise. This is the search result for the Google Ngrams book viewer. This is the frequency of the term unit test in the Google Books data. I really wish it went past 2007 because I'm 90% sure that that graph just keeps growing up. Unit tests, right? That would actually just cover how to verify the change, right? If libutil, or rather, if lib_a just has a nice, reasonable, easy to run, runs everywhere unit testing suite, right? You could make whatever change you want to libutil and see if did it still work, right? Because keep in mind, the changes that we're talking about are not intended to be behavioral or semantic changes. Largely, we're talking about fix up the APIs so that the existing invariants are still holding, right? Existing unit tests shouldn't have to be updated in general, assuming they're good unit tests. Go see that other talk I mentioned. That covers verify the change. How about where and how to change? As it turns out, we've talked about this at this conference. We have published papers on this. We have a tool that is specifically designed to be an extensible platform for identifying and converting an old bad pattern into something better. So that kind of covers the rest of those bullets, right? Upgrades are easy if we, your library vendors, promise not to break you without providing a tool for the upgrade. That tool will identify the places that are affected by the break and perform the upgrade automatically, assuming that we're all writing well-behaved code and being good engineers and providing unit tests. In that world, a complete novice can do the upgrade for a project they don't work in. Keep it locally, submit the patch upstream, whatever. It will not be a silver bullet. Going back to Fred Brooks and the Mythical Man Month essays, tooling is not going to get us double performance, double productivity. We aren't going to magically make these gains. We can't just wave the magic tooling wand and make all of the problems go away. These tools solve one particular class of things extraordinarily well, but they are often constrained by practicalities like, the code you wrote is insane. The deal is going to be this. If your code is well behaved, the tools should be able to enable the types of refactoring and changes that we have collectively been most afraid of, the major version bump changes. Tools are great for doing non-atomic API migrations. You introduce the new API, you provide the tool, wait for people to apply the tool. Then, if necessary and practical, you remove the old API. With these tools and policies, I claim that this is enough to solve diamond dependencies. No API breaks without tools. Users are well behaved. Unit tests everywhere. For source distribution, if you are dealing in binary compatibility and things like that, you are off in a whole different world, and good luck. But the sad reality is, almost anything you can do will break someone's build. So, projects that intend to actually work over time should be clear about what they promise and what they require from you in exchange. I am trying to get the standard to be better about that. Stay tuned. No one can actually speak for the whole committee. There's 100 people there. But I do believe there's rough consensus that we, the committee, will put out something more robust soon. Right now, very few people in this room know what the standard actually says about reserving behavior for future changes. And the standard itself does not say nearly as much as the committee relies upon. So the details in the next couple slides may change before the committee actually commits to something, but roughly I imagine that it'll be something like this. Rule number 1, we reserve the right to add things to namespace std. You don't get to add things to std. This shouldn't be surprising. The standard library is going to expand over time, and we need to not be worrying about whether it's safe to add things to std. Of course, step back. This is a prime example of an engineering rule, not a programming rule. If you know for sure that you will never have to upgrade compilers or standard libraries, and no one else is ever going to use your code, you're never going to share it, it's never going to get off that hard drive, you can add whatever you want to std. Your build's going to work. It's fine. It's not a good idea, but this is an engineering rule, not a programming rule. And it's going to break if you do that and you ever try to share that or upgrade that, and we're all going to laugh at you if you complain about having done that. But there are, of course, some things in std you are allowed to do. For your own types, you're allowed to specialize std hash of t. It does have to be your type. Specifying a hash for some unhashable std type, still forbidden. Specifying the hash, or really anything else, for a type that you got from someone else's library is in general just bad form. You are preventing them from doing the same operation. It makes library maintenance just nightmarish. Don't define things for APIs you don't own. Forward declarations, in the standards case, are a particularly subtle and annoying subset of don't add things to std. You shouldn't forward declare things. You shouldn't add things. Your forward declaration assumes that the details of that name in std never change. And it is not your right to enforce exactly the details of those names if it's not promised by the standard. Right? In an engineering system, you can't add that constraint. That's reserved for us. So let me say that again. You are not allowed to forward declare things you do not own, at least not if you want your build to not break under API maintenance. I pulled this out of boost code from a couple months ago. Here's an example. Don't do this. If the committee decides to add an additional template to an ordered set with a default parameter, so all code that it's building currently continues to build, this 4 parameter forward declaration is now a build break. Congratulations, you have saved your user a pound include in exchange for a build break. Not a good choice. Also, I believe that the standard is going to come to something along the lines of assume the call-only interface. This is going to be bits like, don't take the address of functions. Don't depend on metaprogramming or introspection. Taking the address of a free function in namespace std will be a build break if and when we add an overload for that. So if we decide to put an allocator in the free function for std align, that'll break your build someday. Amusingly, according to Howard, the standard doesn't currently forbid this. You are not allowed to take the address of member functions in std, so you can't take the address of std string size. But there is nothing in the standard, as far as we can tell, that technically forbids you for doing this for free functions. That said, I'm pretty sure I speak for the committee on this one. We super don't care if your build breaks because you did this and we added an overload. There's another important class of usage that the standard doesn't promise is stable over time, metaprogramming. This is a stunningly stupid is even. Take a look. It does the obvious thing in 11 and 14 and becomes super wrong in 17. The type of std vector in placeback changed to return a reference to that new element. Obviously, no one is actually going to write this. This is merely slide code. But you can imagine over 10,000 lines of code building bad dependencies on meta properties of things out of the standard. A huge number of the properties of the standard library are detectable at compile time, and the vast majority of those are subject to change from version to version. Right? This code correctly implements is even in C++ 11 and 14 and becomes completely wrong in 17 because we changed the type of in placeback. Don't do that. So that's kind of an example of this compatibility promise that I think needs to become more clear for all of the libraries that you're depending on. Right? If it is being maintained like at a professional level, they need to tell you what they promise, what they ask from you in exchange. If we're talking about engineering projects and compatibility over time, everything here needs to be understood as a two-way street. The underlying library, be it the standard or boost or anything else, needs to be clear about what compatibility it promises and what it doesn't. It is not theoretically satisfying, but those promises are far more complex than the simplistic semver compatibility story. Semver has lured us in with the idea that we can collapse compatibility down into one concept, brushing aside the fact that it both oversimplifies and overconstrains. It also importantly brushes aside the fact that without real compatibility promises and discussions, and without tooling to ensure that users of a library are well behaved, even a patch release in a semver world can break things arbitrarily. Over the years, we've gone from nothing ever changes, like early POSIX, to nothing changes in a fashion that might break things, both of which can work but are sort of annoying and stagnating. Software engineering is coming up on maybe 50 years, depending on where you draw the starting point, right? And it's going to go for a while more. The idea of something staying completely static indefinitely seems like a bad gamble. In an attempt to rebel against no-breaking changes, we've glossed over the fact that we haven't really defined what is and is not a breaking change. We focus intensely on API breaks and closed our eyes to everything else, pretending that semver solves things. But as our dependency graph grows quadratically, the odds of this becoming unsatisfiable grow as well. So, what if there was a world that worked differently? There is that third option for avoiding diamond dependencies, after all. Make it always easy to update, even for a non-expert. Anyone that's lived in a monorepo has already experienced this. Anyone that's worked at Google in the last 5 years has seen this in action. The burden is on the people making API changes to update their users. We've spoken at length about how we make this work. It also puts the burden on the people making the change to deploy the change, which is a much better scaling property. So go back to the start of the talk. I need to make code inside and outside Google API compatible. That is my mission. We've had years of experience with the upgrades are easy variety of things, and as a result of our policies and our monorepo. And now I would like to offer that to you. So today we're introducing Abseil. Don't go to the website, I'm still talking. We're releasing common libraries with an engineering focus. We want this to work over time. Just like the required fields example, some of what we ask may not entirely make sense at first, or it may seem arbitrary and weird, but I promise you, over time, this will be the right answer, or we'll figure out how to change it to be the right answer. These are the libraries that are used internally at Google. We released soft launch yesterday. I have 250 million lines of C++ code that depend on this. I have 12,000 active developers depending on this day to day. These are the libraries that are used. They're about to be used by other Google open source projects, Protobuf, gRPC, TensorFlow. This is a big part of why we're doing this right now, actually. Things in this code base tend to get written against the same set of APIs, and when we open source them, we don't have a nice canonical supported set of those APIs to work with for the open source releases. So every one of those projects, every one of those teams spends a bunch of effort like hacking their way back out of the code base. We're just going to fix that problem at the root. We've spoken for years about the internal processes and our ability to do large-scale refactoring. I don't want to lose that. Ability to change is important. I've spoken about what it takes to be sustainable, and I'm very proud of having gotten Google's code base to that point. Ability to react to change is a big part of that. But we also don't want to break you, the open source users. We have to be responsible and provide easy upgrade paths. All of that, plus what I've already talked about for the last 40 minutes, if you are well behaved, we won't break you. If we have to make an API change, hopefully it's rare, but we'll ship a tool to just do the update. I don't believe in semver, and I further also don't believe in pre-compiling this. I want you to build from source and build from head. I want you to live at head. If the libraries you depend on are being updated smoothly with the policies like what I've described, and your code is well behaved, there is no benefit to pinning to a particular version. Syncing to the current version of your upstream deps should be no different than syncing with the rest of your code base. Right? In practice, until we work out better mechanisms to ensure that all of your code is well behaved, it is going to be a little tricky at first. But it's a concept, it's not a technology. The more that you can keep your deps up to date, the less exposure you have to unsatisfiable dep problems, the happier you'll be. Plus, you get all the new stuff. We're going to ship some example scripts for Bazel and GitHub that make it easy to sync from upstream when you want to. If you're a larger organization with security policies and the like, that clearly won't apply. But this is a concept, not a technology. Get in the habit of syncing regularly. If something goes wrong when a daily or weekly upgrade is going, check your code against our compatibility guidelines. Maybe we did something wrong, maybe there are things we haven't called out, or maybe your code is just being silly. The more aggressively that we shake those out, the easier all upgrades become. It was a lot harder to do the sort of upgrades that we do internally 5 years ago. We've shaken the tree, and now it's nice and smooth. In the end, remember, what I'm doing here is bringing the APIs and the user experience that Googlers have lived with for years. I am not saying it's perfect or the ultimate answer, but this is what this project needs in order to still have a chance of maintaining velocity for those 250 million lines of code. Excuse me. Let me go into some detail on what you can't do with Abseil code and still qualify as well-behaved. Although remember, this is of course an engineering restriction, not a programming one. If all you need is a moment in time, go ahead and hack away. Just don't come to us if it doesn't work when you try to do an upgrade. We reserve the right to add things to namespace Abseil. Everything on this list has the potential to break existing code just because we added a new symbol. We will eventually get better static analysis, linters, clang tidy checks, etc., updated, public, to catch as much of this as is practical. But I guarantee you, everything on this list is a thing that you could trigger a build break with when I make an internal change, or when I add a new name. We also reserve the right to change implementation details. The ABI will not be stable. Do not rely on, I built this 6 months ago, and now I'm trying to link against a version of it from now. And no, we change things all the time. Don't do that. Don't depend on internals. Any namespace with internal in it, is not for you. Any file name with internal in it is also not for you. Please stay away from those. I know that everyone's like, oh, underscore underscore in the standard means that's reserved for internals, but I can do it just this one time. No, you can't. Don't define private, public, not even once. It's not funny. Don't do that. Our include graph will change. Please include things. Includes are not bad. On the topic specifically of ABI and internals not being stable, I really like, go see Matt Kulakundis' talk Wednesday afternoon for why we find those things so important. If we were constrained by any of this, then our recent work on changing hash tables would have been impossible. Improvement requires change. Duh. So what is Abseil? This is a library. It is zero config. It is a bunch of utility code. It is the low-level nuts and bolts of C++ as we write it. It is string routines. It is debugging and analysis. One of the things I'm really, really excited about is it will include guidance. Internally, for the C++ library team, it's probably been 5 years now, we started publishing a Tip of the Week series, which is sort of a longer form essay about something that's been coming up. These are largely compatible with the core guidelines, just in a sort of longer form discussion. I've been trying for years to have a smooth venue for shipping all of that, and now I finally have a mandate to do it, so that's nice. We have C++ 11 compatible versions of standard types that we are pre-adopting. So if you really want stuff out of 17, but you're stuck on 11, maybe you want to give it a shot. And in a couple cases, we have alternative designs and priorities to the standard. But the general goal for everything is support 5 years back when possible. So let's look at what that means. 5-year compatibility and zero config means we are going to assume the standard, but work around it if needed. Here is an example. The thread local keyword for C++ 11 has been implemented by all of our compilers, everything that we care about. It works fine. But for some reason, in Apple Xcode up until Xcode 8, it was disabled. So we have tagged in here, Apple build version 8. We detect that scenario, and everywhere that we are using thread local, we have to work around it. The other half of this is 5 years after Xcode 8 and the fix has been released, we're going to delete this and all of those hacky workarounds. Right? You get 5 years. We are planning for the future. Abseil is a bunch of utility code, string routines. I'm really amused in the aftermath of Bjarne's talk we were talking about. We'd really like something like a Python split. Like, give me 45 minutes and I'll ship this for you. So we have stir split. It takes stringish things and a variety of delimiters in the simple case, and it returns you a vector of string. Or does it? It actually also returns you a vector of string view, or a list of string view, or your container of whatever. It does a fair amount of nice magic to give you a very powerful, expressive, basic concept, I just want to split a string, and do it in a configurable, customizable, very C++y sort of way. You can also go the other direction, joining strings, a little less magic. One of my absolute favorite things, stircat. This is a variadic, unformatted, just convert it to string and concatenate it, and it is blazingly, ridiculously fast. I've had a number of Googlers say, you know, if you don't release anything else through Abseil, but you release stircat, project is still a success. Is a really simple way of life improvement for, I just need a string, just give me a string. This is debugging facilities. We have leak checking APIs. The API is always there, and if you happen to build your code with leak sanitizer enabled, then the API is implemented by leak sanitizer. If not, maybe you feel like implementing leak checking with some other thing. That's fine. Same API will be there. And your code will always build regardless of what platform you're on. We have stack traces on supported platforms, of course. Get back the function pointers for your function stack. On even more limitedly supported platforms, we're working on symbolizing those so that you get the names of those functions. We have nice built-in ties to address sanitizer, thread sanitizer. You can tell what tools we use internally. And the static thread annotations, I really like those. We are pre-adopting C++ 17 types in C++ 11. So you have string view, optional any, and soon variant. Turns out it is hard to write variant so that it works on all compilers in C++ 11. We'll get there. We're almost there. But wait, you may say, types are expensive. You have heard Titus speak in other forums, and he says types are expensive. So consider, in a C++ 14 code base, you wrote something, Abseil optional foo, returned by maybe foo. Now you want to update to a C++ 17 world, and you don't want to spell Abseil optional, you want to spell stud optional, right? We're in 17, we should use the standard. Clearly you should use the standard. So you have to go track down every place that that is called and update those things in the same change. That's kind of annoying. And then you have to track down everywhere that f goes. So you have to update every function that it passes into. And you can see, like, in theory, this might get actually kind of messy and difficult. Turns out, nope, we planned for this. We check at build time. Are you building in C++ 17 mode? Do you have stud optional? If so, Abseil optional disappears. It is just an alias for stud optional. They are never separate types. They are at most separate spellings. In any build for Abseil, you should have one of stud optional and Abseil optional, and string view and any, etc. This means when you use the new standard, the pre-adopted types just melt away, and you don't have any restriction on how you update those spellings. Both spellings are the same type. So you can just update one file at a time as you feel like doing it, or you can leave it for later. Per the 5-year policy, 5 years after the relevant standard is available, 5 years after C++ 17, we will ship a clang tidy check that updates the spelling everywhere from Abseil optional to stud optional because we assume that you have 17, and then we will delete our version. However, this is important. This is part of why we can't have you relying on argument-dependent lookup on ADL. ADL is one of those surprising bits of the language. When you call an unqualified function, the overload set is formed by looking in the associated namespaces for the arguments of that function. And this means this code works fine in 11 and 14. I have an Abseil string view, and I can call unqualified strcat, and it will say, oh, one of my arguments is from namespace Abseil. I will look in namespace Abseil. Oh, there's an Abseil strcat. Done. My build succeeds. This code obviously breaks when you update to 17 because Abseil stops being the associated namespace of that type. It's stud string view in 17. So if you write your code to depend on things like ADL, you will break over time. Don't do that. We will try to ship static analysis to prevent you from doing that. So don't rely on ADL. Like I said, we're shipping the guidance tip of the week series. There's about 130 of these. I checked very recently. These are cited about 25,000 times a month internally, so it's a little important. We cite them by number, traditionally in code review. So I know the numbers of probably 15 or 20 of them just off the top of my head. If I see you doing something that indicates maybe you don't understand how return values and copies work in C++, I'm going to cite tip of the week 77. And this is just kind of a shorthand for you need to go read that, go read through that, report back, figure out what you've done wrong, etc. So we're going to ship the same ones with the same number. Not all of them still matter in the public. Some of them don't even matter internally. So there will be holes in the numbering system. I hope you can all get over that. I don't want to learn another set of numbers. This is largely compatible with the core guidelines. And in the couple places where we find that it's not quite in line, I really look forward to working out under what circumstances is that guidance the correct guidance, or just fixing ours. So. And then there's standards alternatives, how to alienate my friends on the committee. I promise it's not actually that bad. So the standard, design priorities for the standard. You do not pay for what you do not use. I think this has been mentioned 5 times in talks that I've been to so far this conference. And further, honestly, I'm not sure the committee agrees on a whole lot more than that. But as far as it goes, this is a really important guiding principle for the standard. And it is a big, big part of why the standard works. This is a very good thing. This is the right thing. A side effect of that is for any problem space that the standard is solving, if there is runtime overhead for some design or feature on a reasonable platform or workload, we, the committee, will find an option to avoid it. We will design a different solution. So let's look at the example. Stood Chrono. Chrono needs to work just as well if you are in high-frequency trading where the CPU costs of time operations on nanoseconds actually start to dominate the discussion. Chrono should also work on an embedded microcontroller that has 16-bit 1-second ticks. Clearly, the microcontroller cannot afford the precision and requirements of the high-frequency traders, nor would the microcontroller system even remotely suffice for the traders. And so the C++ solution is, of course, we add a template. Our compromise is class templates. By default, the representation for duration and time point is a signed integer. This leads directly to things like, by default, you can't express an infinite duration, and there is undefined behavior on overflows. That is what signed integers do. And this makes perfect, complete sense in a world where you cannot afford any additional expense, or the safety checks don't matter. But this is clearly not the only sensible set of design priorities or design constraints. What if we wanted something other than don't pay for what you don't use? What if we prioritized safety, clarity, ease of use, and still didn't want to write in Java? So we're shipping time and duration. These are classes, not templates. They happen to be, I think, 96 bits right now, but their representation could change. They have saturating arithmetic. They have infinite future, infinite duration. If you do math on an infinite, it stays infinite. It's never undefined. And asking for what time is it now is usually, the last time I ran a benchmark on this, it was twice as fast. We've optimized because we run a lot of stuff. We also have slight design differences for mutex. Our mutex has a little bit more stuff built into it. It has reader-writer locks. So the standard supports mutex and shared mutex. Once you have built your whole system and you discover that you have contention on that mutex and that you would be well served by changing it to a read lock instead of an exclusive lock, then you have to go thread shared mutex through all of those APIs to make sure that you can take a shared lock. For us, it's just one type. There is a little bit of overhead on that, but it does make the ability to use that feature much more readily available. You don't have to do API impacting refactorings. You just have to go find the places where you're only grabbing it for read, change it to a read lock. In debug mode, we have deadlock detection built in. This is theoretical deadlock detection, not practical deadlock detection. It's not, oh, hey, you seem to be hung. It's, we are doing the graph theory to identify what order your mutexes are taken in by any given thread. And if one thread grabs A and then B, and the other thread grabs B and then A, in theory, over time, sometime you're going to deadlock. We just notify you of that in debug mode. And it also has a slightly harder to misuse API. Notice if you're using the standard mutex, you have to have a separate condition variable. So lock is a mutex, CV is a condition variable, and you specifically have to trigger something on the condition variable to say, hey, done. Abseil mutex, note the major differences in that finish. Abseil mutex, when you unlock, the mutex says, is anyone waiting? Can I check any of these conditions? And then it goes and evaluates the condition. You can't, it's harder to misuse because you can't forget to signal, which is kind of nice. A build input, there are very, very few flags to the build for Abseil. We try to intuit everything from compiler inputs, things that are provided by your toolchain, not things that are user specified. One that we do have is Abseil allocator no throw. The standard, go back, wants to be applicable everywhere, but it is also very hesitant to allow the possibility of build modes at the standards level. I'm going to be pragmatic. In some cases, the result isn't entirely satisfying. So many platforms don't have throwing allocation failure. If you allocate, there's no memory available, your process crashes, or the operating system killer starts killing off something else. However, because the standard allows for the possibility that all allocation is an exception, any type that may allocate during move construction can't be no except. Vectors of all of those types are slower to resize. Using a vector of a type on a platform where you aren't actually going to throw, every time that you resize that vector, you are paying. Abseil recognizes that this is annoying and provides build system hooks so that you can define centrally, does my default allocator throw? And guidance for how you can tag your own move constructors accordingly. Then, if you build on a non-throwing platform, vectors of those types just work better. And on throwing platforms, it's all still good and compatible and correct. We aren't saying that you can't work on a platform that throws. We're just saying that many of you aren't on one. And maybe you should have a more efficient vector resize. We are not competing with the standard. Standard is still much bigger. These aren't better designs. These are designs resulting from different priorities and different engineering legacies. You should decide which set of priorities works for you, and the standard is still unquestionably the right thing for interoperability. That's a brief introduction for Abseil. Before we wrap up, let's circle back around and get kind of the big picture. With Abseil as an example, let's consider what makes C++ particularly well-suited, or not, for live at head, title of the talk after all. We have some challenges. We don't have standard build flags or build modes. The one definition rule makes pre-building anything with potentially different build configuration very dangerous, very bad. Taken together, these mean that source distribution is pretty common. And while these technical challenges in general, every challenge is an opportunity, and the result of source distribution being as technically necessary as it is in C++ means that live at head is maybe more useful, necessary, and impactful. I also think it's the case that C++ is a particularly challenging language. Maybe it is because I am so steeped in it, but to me it feels like other languages provide fewer surprising mechanisms for a change to break a remote user. Like, if we were doing Abseil in Java, we wouldn't have rules like don't depend on ADL or don't use the global namespace. I'm not sure there's Java equivalents that have the same language level subtlety. Maybe they do. Maybe I'm just not up enough in Java to know where all of the pitfalls lie. But by reputation, I do suspect that we're special here. This all means that we have to be a little bit more clear about what we require from users. Also on the downside, the lack of a standard build system does make all of this more challenging than it would be otherwise. On the upside, we don't have a standard package manager. Something like a live at head world is not going to fly nearly as well in Python, where the community has completely formed around this is the way that we do dependencies and package management. We do have good and consistent unit tests, according to a recent Stack Overflow survey. For C++, if you take Google test and Boost test, that covers about 75% of unit test framework usage, which is nice because it means you, the non-expert, can run the tests for a thing that broke without having to know a whole lot about how do I even run these tests. Right? There's only a couple options. And of course, in order to make tooling work, we need good tooling. The things that we do these days on a pretty regular basis would have been waved off as clearly impossible 10 years ago. It is still not perfect. We're missing off-the-shelf support for some common patterns. But it's all incremental things that are missing, not the core revolutionary tech. It's like we've invented cold fusion. We just haven't quite figured out how to rig it up to the power grid. Or maybe we've got cold fusion, but it needs a slightly different distribution network. And so we need to build that out and demonstrate demand at the same time. And so the call to action. Concretely, what does it take to push us as an industry and a community from where we are to a live at head world? I need you to consider engineering versus programming. When you're doing a thing, what is the lifespan of that thing? Does that need to live indefinitely, or does that need to live until Thursday? You need to be aware that there's a difference between those, and you need to behave differently. I said in a talk over the summer, computer programming right now is one of the only domains I know of where there's something like a 4 order of magnitude difference between how short something might live and how long something might live. Right? It is entirely possible that you write a thing and you are done with it the first time it runs. And it is entirely possible that you write a thing and it lives for 50 years. It is insanity for us to believe that the same rules and guidance and principles apply on both ends of that spectrum. Please be aware of what you are doing. Understand your dependencies. What does the standard provide? What does the standard ask of you? Behave accordingly. Write well-behaved code. I need a better term for this. I really sort of wanted it to be up to code, but that was confusing. Use the up-to-date versions of things. Right? Don't pin to some 6-month-old dependency if you don't need to. Apply tools when provided. Write tests. If you can do all of this, if we can change the way we conceptualize change, especially this ridiculous idea of breaking changes, if we can understand the engineering quality of libraries that we depend on rather than just the programming sufficiency, we can find a far better world. As users, if you help us by living ahead when you can, cooperating with us as we figure this out, will help lead you to a better world. As library authors, if you follow these same ideals, tell your users what to expect, make change carefully, and make it easy to work with, will help lead you to a better world where you can make the changes you desire without harming your users. It is going to be a bumpy road to get there. Change is not easy, but I have been saying for years, it is important that it is possible. That is true for code, and that is true for communities. And I hope it can be true for this one. And of course, Abseil is no different. We'll change too. There will be a whole bunch of more stuff that comes. This is just the initial drop. My plans go out probably at least 3 years. While you are still here, I really recommend sort of spiritual follow-up talks. Matt Koulakundis, I mentioned earlier, is talking about Google and hash tables on Wednesday. From my team, John Cohen is talking about what it takes to move to rename a type. We've learned a little bit about that in the last year. Gennady Rosenthal will talk about ABI issues and part of why it is so important that you not depend on a precompiled representation of this code. And also today, I will give a hands-on with Abseil, assuming I'm still conscious, which should answer some of your additional questions here. I cannot even remotely claim the lion's share of the responsibility for this. This is the work of many fine people. Thank you all so very much. And volunteers not quite on my team, some former team. And for those of you from my team that are watching this remotely, I recognize that you have more important things going on. Thank you for bringing up the next generation of Abseilers. And with that, I will turn it over to the audience for questions.
It's well known that Google Codebase does not support or use exceptions.
True.
How well does Abseil play with exceptions?
It is aspirational. So by that, I specifically mean I'm not aware of any glaring places that it's a problem. If you can identify, oh, this obviously needs to be exception safe and currently isn't, we'll definitely accept that patch. A low-level library needs to be supportive of all comers. That said, there are places, not all exceptions are smart. If you decide that your hash functor is going to throw, I'm just going to tag it no accept and laugh at you. There are some things that just are completely preposterous and not a good design. Like exceptions should not work everywhere. They should work in sensible places. And we'll try to make that work. But it's going to be sort of a balancing act because, yeah, it's not our area of expertise. So we'll have to learn from you.
Hi, thank you for the great talk. My question is about compatibility and new features. So unified call syntax, also known as, in different languages, as extension methods. What kind of concerns do you think there are on implementing them, or how could the standard move forward to actually have something like extension methods?
So my concern with unified syntax initially is specifically, I don't want you extending my types. Because if I then need to add that same API, I'm constrained by what you did, or I'm breaking your code, or it's a semantic change, right? I would be perfectly accepting of unified syntax not as arbitrary user gets to arbitrarily extend my library. I would be perfectly happy with unified syntax as you can have extension points within the same module boundary, things like that, right? But I need control over how you use my library. And the initial proposals for unified syntax, I was concerned.
Okay, thank you.
Yeah.
Hi, you talked about the kinds of guarantees that Abseil makes and what you think the standard will make, and you mentioned the notion of a call-only interface.
Yes.
So, I mean, it's quite common in C++ if you write, generic code to have to, check these sort of things. So basically things like if you wanted to check is constructible as opposed to actually constructing something, that wouldn't be covered. So basically, if you're an application developer, but you have to write some piece of generic code for your company, for your use case, you have no guarantees at all from the standard or from Abseil.
True.
I mean, at that point, it just sort of makes it tempting. Why depend on Abseil if your generic code doesn't have any guarantees? Just keep writing your own generic code all the way down.
There is the question of, true. And if you want control, it's on you to control it. But that said, there's a difference between no guarantee and it's not going to work, right? If you are checking if it's constructible in order to construct it, and then you construct it, that's one thing. If you are checking if it's constructible and then you go do a computation or some random other thing, right? That's a completely different, that's a horse of a different color. And the issue becomes, it is easy for us, it's far easier for us to specify there's no guarantees if you depend on these sort of meta properties of things. Because listing off the things that you could potentially use the existing behavior for in a way that's likely to be fine in the future, I don't know how to come up with that list, right? And when in doubt, a big part of why today is a big deal is I don't get to live in my little hobbit hole of internal Google anymore. I have to participate with the rest of the world. So if you have, hey, I would like to depend on this, you could ask, right? Well, send us an email. We'll have a discussion. Be like, no, you're completely insane. Or, yeah, I can't actually imagine how in practice that's going to be a problem. You're fine, right? But for things as complicated as programming, it's awfully reductive to try to just narrow it all down to something that can be pithily written in a list, right? In practice, asking is a really good answer.
Thank you.
Yeah.
Hi. As far as I know, Google has a very large coding base. On some of your slides, I saw a tool name like Clang MR. Do you really store your code at MapReduce and run Clang at MapReduce to make refactoring? So the code base is, I mentioned, about 250 million lines of Google-authored C++ code. It is big, yes. The original refactoring tools that Chandler initially cobbled together to give my team, these were MapReduces. The code base itself is not stored in a MapReduce. I don't think that's quite what you meant. But you do basically
parallel build and run the tool over each translation unit separately and then reduce it down into, like, to get rid of the dupes and headers and things like that, so that you can generate a set of edits across the code base. ClangMR is not going to be what we rely on because the MapReduce infrastructure, two things. One, the MapReduce infrastructure isn't quite the right thing for the rest of the world. And two, largely we wind up doing that because our code base is freaking bananas huge. For most people, a Clang tidy check and run it overnight on your code base should be fine.
Thanks.
First of all, thank you for the great talk. I'm an author of a third library, and I'm interested in how to make the upgrades easy, as you said. Specifically, what do you suggest should be in the tools? Like, should I provide tools for my users to upgrade quickly, and how should they work, or like?
So, is the question how do they upgrade? Like, what version of the library is checked in, or how do they upgrade their usage of the library to an incompatible API?
The first one. Like, what do you suggest should be in the tools to make it?
I don't think it's your responsibility to provide tools for your user changing their version. The user should know that you are providing something that will be stable and accurate over time, and should just upgrade aggressively. Live ahead.
So what is the purpose of the tools, actually? Yeah.
The tools are for when changes to the user's code are necessary in order to react to a changing implementation or API when they do that update. Right? Okay. Their build will break or their code will not execute correctly as a result of some change in their underlying dependency. Tool to execute, fix their code base, move on.
I see.
Yeah, and the point is, we have 250 million lines of code already depending on this. When we make a change, we have to automate it. Shock. Right?
Okay, thank you very much.
Yep.
Do I see both snake case and Pascal case in your public API?
Yes. So we snake case when we are specifically trying to match something out of the standard, and we Pascal case or camel case because that's how the vast majority of our code is written.
All right. Well, already ruined. No, it's okay. It was just a joke. Thank you.
We have initiative at my company that is quite similar to this library, where we do implement like the future standards and some proposals and more general tools that could be used in all parts of the organization. We're actually the 3 people who made most of that library are here today. But I had one more technical question regarding your ADL
Yes.
Requirement. Do you rely on ADL internally in your library?
Generally not. There may be a couple places that snuck through, but I believe that we have explicitly qualified everything. Not fully qualified, but everything is tagged Abseil. Partly because we want the implementation and usage and testing of our code to look like how the user is going to use it, so that we know more fully, like, does that look right?
Okay.
So,
Thank you.
You gave an example of, for example, pre-Xcode 8 workaround,
Yes.
which you outlined in a library. And you said that you have 5 years rule after which you remove it. I wonder how are you going to maintain it, because it should be enormous number of places in the library where you have some kind of stuff, and it should be just like human readable, and then when you come over it, you feel free to delete it, or you have some automated tooling around, hey, like this date has passed and this code is automatically eliminated.
There's not enough of those that automation is going to ever pay off. Like, I think there's probably, I don't know, 20 or 30 sort of workarounds that we've got in there right now for those sorts of random, odd little technical glitches. And spending any significant time on automation to work around 20 or 30 things, it's probably not worth it. Like, it's much easier to just have a reminder set for 5 years from now and have it pop up in your inbox and be like, oh, hey, I get to delete 100 lines of funky code today. Yay. Yeah.
Cool. Thank you.
So I was curious about the ADL thing. Like, a lot of operator overloading uses ADL, and I think you like kind of covered it in the talk, but like, I want to be able to like use cout on a string view, and like that uses ADL. So, like, how do you expect to solve that? Like, I just want to do like std cout.
You don't need to use ADL for like function invocations. Everything's gonna work fine in the normal expected fashion. Like cout is gonna work just fine. It is really just unqualified calls, especially into Abseil, where things become a problem.
So it's not like don't use ADL. It's like don't use ADL for function call, or don't rely on ADL for function calls.
Don't rely on ADL when you're just being lazy. If it's an API that specifically necessitates ADL, like IO streams, then yeah, like that's sensible. Like do that.
Cool.
Yeah.
Yeah. Hi. I got 2 questions. Number 1, is Windows a supported platform for you?
Yep.
All the way, including stack trace and stuff?
Nope.
Okay.
We'll try. It is not our area of expertise. Like one of the things that I really like about all of this is the stuff that's running in production, right? This is battle tested. But much like any given army in a battle, right, is battle hardened against the things that they've experienced, right? Like the Crusaders, battle hardened, won't matter when the Martians show up, right? So I'm sure that there are going to be things that surprise us when we branch out into deeper and more lasting ties onto other platforms, and we'll try to work around it.
Okay, and the second question is, now you advocate providing tools for library vendors so that they can upgrade their users. Does that mean that every one of us has to provide like a Clang plugin or something, or how do you see this working?
I think the tooling story is evolving. For us, like our bread and butter is Clang tidy plugins. I really hope that this spurs more innovation in having other platforms that do that. I recognize that there are going to be some Windows code bases that still just can't build with Clang for whatever reason. And we're going to have to negotiate all of that. But a big part of all of this is a lot of what we're currently doing is, in theory, one thing. And in practice, the world is a very different place. And so I'm just going to try to push it all down into, let's just be practical. Let's just do these things in practice and see how it works. And if it's insufficient, then we'll know where to invest more resources going forward.
Okay, thank you.
Yeah.
Okay, so we leave it ahead and we do not pin ourselves to a particular version of a library, and we build from sources. Well, it's great, but what about build times?
Buy another CPU. Use AWS. Like, I don't know. Like, this is also a place where our priorities are going to change, are going to show through, right? Our experience is we have a really massive build farm. And I don't care about you adding an extra include. And I know that that's not everyone's experience. It may turn out that that makes it impalatable. But practically speaking, build times are an annoyance that is also a solved technical problem. It is one of resources. Maintenance of a library and an ecosystem is not a solved technical problem. And we need to claw back some of that in order to solve it, or have a prayer of solving it. So we'll see. That said, I can build everything on Abseil on a laptop in 30 seconds. So
effectively you are saying that build times is not on the top list of your priorities.
no. Build times is a programming problem. I'm trying to plan for how does this work for the next 10 years. That's an engineering problem. Sorry.
Okay, thanks.
Hi, I got a quite similar question. Even if we can resolve the build time problem, because I don't know, we get some infrastructure that as awesome as yours, there's still the issue of software that we release, like, not daily, but every 3 months or 6 months, and that we have to support for 5 years or even 10 years. Can we still live ahead with that?
Maybe. It's going to be very dependent on exactly what promises you're making in that code. It's going to be dependent on, are you exporting Abseil types through your APIs? Because that's a whole different world. There's not a single simple answer, because fundamentally all of these things are really, really complicated. Right? I say often, software engineering is solving the hardest current solvable problems, right? Because everything else is easy, it's already been solved. And everything that isn't quite solvable is off the other end of the cliff, right? So everything that we're doing here is solving the stuff on the ragged edge, and we're trying to build better and better infrastructure for leaning further out the cliff. It's not going to be easy. There's not a off-the-shelf.
All right, but what about, I don't know, I have a bug that I have to fix and rebuild for a 5-year-old version. If you do not provide versioning, how do I, get your stuff and rebuild everything from 5 years ago?
You should, in that instance, probably pin to a 5-year-old version for your 5-year-old maintenance thing. And practically speaking, I recognize that not everyone is going to be able to pull off the whole live at head thing. One of the things, as protobuf and gRPC and et cetera starts depending on us, rather than have willy-nilly releases of that growing dependency chain, what I'm going to do as a practical nod is every 6 months or so, we'll just tag whatever is currently there and say, we'll support this for a couple years if anything important comes up. I don't recommend that. It doesn't scale. But practically speaking, this is a big ship. It's going to take a while to steer it.
Yeah, I'm on board with that. Thank you.
Yeah. And I think we got one more time. Oh, Eric. Sounds good.
Hi.
For anyone else that was in line, I will do a bunch of questions in this afternoon session. So please take a look at the library and come with questions, and we'll talk then. But Eric.
So first, congratulations on releasing Abseil.
Thank you.
So package managers, I think I heard you say that you think the lack of package managers is actually a boon to the live at head philosophy. I tend to be of the opposite opinion, that the lack of package management is one of the things that holds C++ back. So did I hear you correctly, and do you see the lack of package management as a good thing, or would it be possible to have package managers that work in the live at head world?
Yes, I believe there would be. There's definitely, in theory, package management systems that work better for live at head, right? If we just do a thing that is, hey, here's semver again for C++ code, and if you use this toolchain, here's precompiled code, and otherwise, I guess maybe we have source distribution, and maybe we have compatible build systems, and I don't know what else. That's not going to solve anything. That's just going to lead us more down this path that I don't think works. And I think there is a solution where we make it clear where does the code live. We make it clear how to pull it. We make it clear what is current. And that would be great. I think that would be a much better world. So it's not all package management is inherently bad. It's just the most likely scenarios seem like bad ones.
Thanks.
Yeah. Thank you all.
Bash Films can shoot your event with multiple cameras, link to presentation slides, add titles, and edit your event live for a full broadcast experience.
How is this even working? So this is actually a more interesting program to look at in a lot of ways. So let's profile it. Give it a little bit of time to do a profile for us. Let's see exactly what it is that's making this faster or slower based on the different inputs. I mean, you can really gain a lot of insight by actually looking at the profile like this.
I worked at Sesame Street. I got brought on to be a writer's assistant on a show called Sesame Street English, which was to teach English to kids in China and Japan. It seems very simple, the shows that they put together, but it's actually really hard to design a show that is not only for young kids, but also the parents.
Confession like this is therapeutic. I hope you all get something out of this, but if you don't, the therapy will have been good for me, so thank you. 7 years ago, I wasn't working at Google. I was for my previous employer, which was a large multinational investment bank. I had what was up to that point the worst day of my career.
And then came the anger at ourselves because we knew we were responsible for America's first space disaster. We wrote 2 more words into our vocabulary as mission controllers: tough and competent. Tough meaning we will never again shirk from our responsibilities because we are forever accountable for what we do. Competent will never again take anything for granted. We will never stop learning. From now on, the teams in mission control will be perfect because as a team, we must never fail.
One other thing. We're all in a very fortunate position. We've been very lucky in our lives and so forth. And I think as part of the mission, it's also good sometimes to take that fortune and give back. To make sure that we take this platform and use it towards worthy causes. That's good karma. That's good stuff in the universe.
We understand that your event will have needs that are specific to your organization. Please email or call us directly to discuss your particular event. We look forward to discussing your goals and helping make your event a success.